Hello there, this is Professor Shannon Gracie, and we are now on section 4.2 of Robert Blitzer's Introductory and Intermediate Algebra combo text. We will be covering today how to solve systems of linear equations using the substitution method. So last time we learned how to solve by graphing, and this time we're going to learn using the substitution method. So go ahead and warm up. The first two warm-ups here. One of them is, One of them is solving a linear equation in one variable, and then the next one is what we did last time, solving by graphing. Okay? Go ahead, pause the movie and warm up. All right, let's see how you did today. Here we go. We need to distribute the 3 throughout this quantity. So we'll get negative 5x plus 3 times 2x minus 3 times 7 equals x minus 21. Negative 5x, and by the way, this was the result of the distribution, plus 6x minus 21 equals x minus 21. This will give us x minus 21 equals x minus 21. And let's see what happens. If we get the x's on the left, we'd be subtracting x from both sides, and getting the constants on the right, we'd be adding 21 to both sides. And let's see what we ended up with. Do you see we get 0 x's plus 0 equals 0 x's plus 0? And what the heck does that mean? 0 equals 0. This is one of those weird ones. So what would you think? Is that true or false? Yeah, sure it's true. This is true. And what did it mean when you got a true statement like that? Good, it means that x can be any real number and it won't change the value at all of this equation or change the solution. So we have to write the set builder. Our variable is x, such that x is a real number. And yes, you have to write that out. How'd you do? Great. I hope that those are getting a little less strange for you. Okay. Let's see, we'll go ahead and just use the regular scale here. We've got x and y. 10 down to negative 10. Okay, so if we go ahead, I'll do this guy in blue. And since y is isolated, what's a good format to use? Great, slope-intercept form is a good format to use. So here we will get m equals negative 4. So I'll go ahead and I guess have that be 4 down over 1 right. And then the y-intercept will be the ordered pair. Sorry, my dot went a little crazy there. Will be the ordered pair 0, 6 because of this guy here. And here was our slope. All right, so graphing, we'll go to 0, 6, 2, 3, 4, 5, 6. And then we need to go down 4 and 1 to the right. 1, 2, 3, 4, and then 1 to the right. And I'm going to do a couple more to keep myself straight. So 1, 2, 3, 4 up, and 1 to the left is also equivalent. 1, 2, 3, 4, 1 to the right. One, 2, 3, 4, 1 to the right. 1, 2, 3, 4, 1 to the right. I don't like how that ended up. Okay, so we've got the blue line, and then we'll do the other one in green. Okay, so this slope is -2, and the y-intercept is the ordered pair 0, 0, right? Because there's nothing added or subtracted to it, so it's 0, 0. And so we can have this slope be, we can do 2 down and then 1 to the right. And again, here's our slope for the second one. And let's go ahead and get that graphed. So we start at 0, 0. We go 1, 2 down and 1 to the right. 1, 2 down, 1 to the right. And then look, see, this is going to be our intersection point here. So the name of this graph is y equals -2x, and the name of the blue one was y equals -4x plus 6. And our intersection point is here. And what is the intersection point? That's right, the intersection point is the answer. So I think it's over at 1, 2, 3. Let's see, 1, 2, 3, and then 1, 2, 3, 4, 5, 6. So 3, -6. And so our answer is the ordered pair, 3, -6. And we're done. How'd you do? Awesome. All right. So moving right along. Once this saves, here's some steps for solving a system of two linear equations containing two variables using substitution. So first up, you need to solve one of the equations for one of the unknowns. All right, you can either isolate x or you can isolate y, and I usually just pick the one that is the easiest. Now here's the important thing. If you're using substitution, once you've isolated the variable in one equation, you have to take that expression and substitute it in for the appropriate variable in the other equation. If you do it in the same equation, you won't get anywhere. All right? So substitute the expression solve for in step 1 into the other equation. The result will be a linear equation in one variable, which you know how to solve. That's what we were doing in chapter 2, I think. Right? Then solve the linear equation in one variable that you found in step 2. Then back substitute. The value of the variable found in step 3 into one of the original equations to find the value of the other variable. And it's always good on that as your last step to check your answer by substituting the ordered pair into both of the original equations. Okay, so let's check it out. Now this one, you've got two equations. So, organization is key in these types of problems. So this is what I recommend. Name each line. Why don't we name this guy A and this guy B? Okay, these are going to be their names. What I'm going to do is I'm going to, write this out in steps, and I'm going to show you what all we're up to, right? So our first step, okay, is I'm looking at equation B, and I see that y has a coefficient of -1. So it'd be very easy to isolate the y without getting any fractions, right? So I'm going to choose to isolate y in equation B. Okay? So here we go. Equation B is 3x minus y equals -14. So if I subtract 3x from both sides, I'll get negative y, because we get 0 x's is 0, is equal to -3x plus 14. And then I need to multiply everything by -1 so that I can get a positive 1y. And don't forget that negative, we have to distribute that binomial. So we will have y is equal to positive 3x minus 14. Okay, next step. Second step. Substitute y equals 3x minus 14 into which equation? Good, equation A. All right, you got to use the other equation. Right? And this is going to enable us to solve for which variable, you think? Good, we'll be able to solve for x. So let's do it. So it starts out as 5x plus 2y equals -5. Now, substituting in the expression for y, we have to substitute in 3x minus 14. And that's equal to -5. So what we did here, this is what y equals, right? So we're going to be substituting, no, I'll do the y. Substituting here, okay? Alrighty, so now we get, oops, I'll be consistent on my colors. 5x plus 2 times 3x is 6x's, and then minus 28 is equal to -5. So then, oh, you know what, guys? Remember, you're supposed to stop me when I make up my own math. I'm looking over here. See how we had 3x minus y is -14? All right? Bad teacher, right? So here, let me make some adjustments. This is going to be a minus. That's going to turn this into a plus. Right? So we'll have plus 14. And this will be a plus 14, which will make this a plus 28. All right. Now we're back on track. So this gives us 11 x's, right? And then taking that 28 to the other side, do you see we'll get -33? Now when we divide both sides by, or multiply by 1/11, that's how we've been showing it thus far, we will get a result of x is equal to -3. Are we done? No, good. We have to find that y coordinate. So the next step, substitute x equal to -3 into, and now you can use any equation you want. You can use equation A, you can use equation B, you can use how you've isolated the y over here. I'm just going to go ahead and do it into equation B. And then this will let us solve for y. So equation B was our 3x minus y equals -14. Okay, so now remember we had found x here. So in for x, we're going to be putting -3. So that's what we substituted in. So we get -9 minus y equals -14. If I add 9 to both sides, I'll get -y is -5. And then I just need to multiply or divide by -1. And I'll get an end result of y equals +5. Okay, so now we need to have, a conclusion here. You need to, this is grown-up math. We need to write this. We need to write a conclusion. So what have we found? We've found that the ordered pair -3, 5 is the solution. And by the way, this is consistent. It's a consistent system. And we're done. Again, the greatest advice I can give you on these problems is organize your work. If you organize your work, life is going to just be so much easier for you. All right, so now let's go ahead and I'll have you guys work on part B. You see if you can do that on your own. All right, pause the movie. On your mark, get set, go. Okay, let's see how you did. The first step, notice that both of these guys are isolated. Okay, so I'm just going to say for the first step, since we already have something isolated, we're going to go directly to substitute y equals, and these are equation A and equation B, y equals 5x minus 3 into equation B, and this will enable us to solve for x. Okay. So here we go. We start out with y equals 2x minus 21/5. We're plugging in 5x minus 3 in for y. So this is what we did here. And now I'm going to go ahead and it's up to you. Should we clear the fractions out? Sure, why not? So if we multiply both sides by 5, right? And don't forget, we need to distribute both sides. We'll get 25x minus 15 equals 10x minus 21. Okay? Because 21/5 times 5 is 21. So now subtracting 10x from both sides, and so we'll subtract 10x and then add 15. We will get 15x is equal to, let's see, it looks like -6. And then multiplying both sides by 1/15, we'll get, go up here so we have enough room, x is equal to -6/15, and I believe we can reduce that to be x is -2/5. All right, so then next step, we will substitute x equals -2/5 into, why don't we go ahead and do equation A. This will let us solve for y. So we have y equals 5x minus 3 is equation A. Y equals 5 times -2/5 minus 3. So the x value is the -2/5 we're substituting in. The 5's will divide out, so we'll get y is -2 minus 3. Y equals, -2 minus 3, and y equals -5. Alrighty, so this time our third step will be the conclusion. So in conclusion, we got the ordered pair, -2/5, -5. That's the point of intersection. And what kind of system is this? Good, it's consistent because we got an answer that made sense. Alrighty, so next up, we'll talk about some of the crazy ones, or unusual, we'll say. Suppose you're solving a system of equations and you end up with 5 equals 0. Does that sound okay to you? Right, not unless we've been hitting those margaritas again, right? So this is a contradiction, right? It's not true, it's a contradiction. And yields a result of either the empty set, which I prefer to use, or you can denote it like that. This system consists of two, what kind of lines? What kind of lines never cross? Good, parallel lines. And they never intersect. All right, other situations. Suppose you're solving a system and you end up with 5 is 5, or x is x, or 0 is 0. This is an identity, right? It's true. And yields a result of all good ordered pairs. Which are on the line, because remember, if you get a situation like that, the system will have infinitely many ordered pair solutions, and it consists of two lines which are identical. Okay? Okay. Example 2. So I thought I just am telling you ahead of time that normally you wouldn't do both things. You would not graph and solve the system using substitutions, using substitution. But I just wanted you to see a picture of what goes with what. All right. So here we go. Name our lines. Okay. And you know, just for the heck of it, why don't we isolate x this time, right? So if we were to isolate x in equation A, we would get isolate x in equation A. And again, I'm just doing what I looked at and thought would be the easiest, right? And so we'll have negative x plus 3y equals 4. Negative x equals negative 3y plus 4. We need to multiply both sides by negative 1. And that will again distribute through the binomial. So we'll get positive x is 3y minus 4. Next up, substitute x equals 3y minus 4 into what equation? Good. We have to do it in the other equation, which is equation B. And this will enable us this time to solve for y. So 2x minus 6y equals negative 8. 2 times 3y minus 4 minus 6y equals negative 8. This was the substitution this time. All right, so this, I'll bring this up here so we have some room. This will give us a result of 2 times 3y. Remember, we're going to distribute the 2 throughout. So we'll get 6y minus 8 minus 6y equals negative 8. So do you see we'll have 0y minus 8 equals negative 8. And then that just gives us negative 8 equals negative 8. What do you think about that? Good, that is definitely true, right? So our conclusion for the system is what? Yes, it's that odd one, the set notation. It means that as long as the ordered pair is on the line, so x comma y such that, now you pick. Why don't we pick line A, right? Negative x plus 3y equals 4. So as long as they're located on that line, that's the solution. All right, so let's make a, and by the way, this is a dependent system. Dependent are dependent equations, and the system is consistent. Okay. All right, let's see what this looks like. Okay. So we would have x and y. And I'll graph this guy in blue. Now if I use intercepts, I'm going to go a little faster here. If x is 0, y will be 4/3. So I guess I'll do it over here for the blue line, x and y. If x is 0, y would be 4/3. And if y is 0, x is good. X is going to be -4. Okay. So 1, 2, 3, 4, 0. And then 0/4 will be about here. Alrighty, and then graphing this guy by intercepts. Do you see that x and y? So if x is 0, right, I'm coming over here. Do you see y would be -8 over -6, which reduces to be 4/3. And if y is 0, x is going to be -4. What do you know? Same 2 points, which means we have the same line. Right? So this line has a nickname, right? The nickname is 2x minus 6y equals -8, and its given name could be -x plus 3y equals 4. Okay, why don't you guys try part B and see how you do, right? Pause the movie and start part B. Okay, let's see how you did. So for the first step, again, I think isolating x will be a good move, right? So this is our equation A and equation B. Isolate x in equation A, and this will let us solve for, oh, nope, not yet, sorry. That'll be the next step. So we have x minus 5y equals 3. Adding 5y to both sides, we'll get x is 5y plus 3. So next step, substitute x equals 5y plus 3 into which equation? Good, equation B. This will let us solve for y, or at least that's the plan. So -2x plus 10y equals 8. -2 times 5y plus 3 plus 10y equals 8. So we're substituting in for x. Okay. So distributing, do you see, we'll get, I'll show more work on this one. -2 times 5y plus -2 times 3 plus 10y equals 8. And then coming up here, this will yield a result of -10y minus 6 plus 10y equals 8. This gives us 0y minus 6 equals 8. -6 equals 8. Is that true? No, definitely not. This is false. It's a contradiction. Right? So our conclusion is that there is no solution. No solution. And we write that in Mathese like this. Right? and this system is inconsistent. There we go. Now, the graph of this, again, we can use intercepts or whatever you want to do. I'll do this one in blue, right? Or actually, just for the heck of it, let's get these into slope-intercept form. So x minus 5y equals 3. That will give us a result of negative 5y equals negative x plus 3. And then multiplying both sides by negative 1/5, we'll get y is equal to 1/5 times x minus 3/5. The green line, well, we'll go ahead and finish the graph. So m is positive 1 over positive 5 or negative 1 over negative 5, whatever you want to do. And the y-intercept is going to be 0, negative 3/5. So 0, negative 3/5 will be just below the 0, negative a half. And then if I go up 1 over 5, I can get another point here. Oops, there we go. And it's going to look something like this. I don't like that second one. Okay, something like that. And then the green line will be negative 2x plus 10y equals 8. So that'll give us 10y is positive 2x plus 8. And then multiplying both sides by 1/10. Remember, that distributes through. We will get a simplified result of y equals, so 2 over 10 is 1/5 times x, and then 8 over 10 is 4/5. So our slope is the same, and look, our y-intercept is different. Our y-intercept is 0, 4/5, which means we have good parallel lines. So 0, 4/5 be up here somewhere. And then, so up 1 and then 1, 2, 3, 4, 5. It'll look something like this. So this one is named negative 2x plus 10y equals 8, and the blue line is named x minus 5y equals 3. They're parallel. Okay, example 3. This one's a thinker. We want you to write a system of equations that has infinitely many solutions. So let's look at this one. Look at these two lines. Look at these two lines. What would you say they are? What if you multiplied equation A by negative 2? Just kind of visualize that. Are you seeing it? All right, if you multiplied equation A by -2, wouldn't you get equation B? Yeah. So that means that if you have two lines that are multiples of each other, then they are the same line. So if we need to come up with a system that has infinitely many solutions, right, then you can pick whatever you want for your first one. What do you guys want to do? How about, I don't know, 5x minus 12y equals 3. Sound good? Okay. Now, let's multiply by, this is what we're thinking. What do you want to multiply by? You want to double it? We'll just double it, okay? So if I took 5x minus 12y equals 3, and I doubled it, I have to double both sides to balance everything out. And then distribute that left side through. So then I would get, 2 times 5x minus 2 times 12y equals 6. 10x minus 24y equals 6. So I come over here and I say, oh, 10x minus 24y equals 6. This system, these two lines that make a system, will make a system that has infinitely many solutions. All right, applications. Now, we're going to be covering this in more depth in section 4.4, but we can at least, get started here. So, first one, Krista is a waitress and collects her tips at the table. At the end of the shift, she has 68 bills in her tip wallet, all ones and fives. If the total value of her tips is $172, how many of each bill does she have? All right, so remember we do our step-by-step process here. So first step, analysis. Okay, we need to name our variables. Okay. So let's see. At the end of the shift, she has 68 bills in her tip wallet, all ones and five. Okay. So why don't we say, to name our variables, let x be the number of ones and let y be the number of fives, right? Because at the end of the day, we need to find out how many of each bill she has. Okay, second step. Translate to mathese. Right? Translate to math. So we already have our first statement. Overall, she has 68 bills. So how do we write that in math? I mean, if x is the number of ones and y is the number of fives, what's our first equation? Good, it'll be the number of ones plus the number of fives equals 68. So using our variables, x plus y equals 68. Okay, next up. The total value of our tips is $172. So the first equation dealt with how many of each bill. Now we have to put a value to each bill, right? So what is a $1 bill worth? Good. 1. So 1 times x, and then what about a $5 bill? Good. 5 times y is equal to, good, 172 bucks. Okay, so now, next step. We need to solve the system. In this case, we get a system of equations. So let's go ahead and rewrite the system. X plus y equals 68, and then 1x is the same as x, plus 5y equals 172. And we can name our equations A and B. So the first step in solving the system, I'm going to go ahead and going to isolate x in equation A. Equation A. So we have x plus y equals 68. So x is negative y plus 68. Second step. We need to substitute x equals negative y plus 68 into equation B. And this will enable us to solve for y. So x plus 5y equals 172. X was negative y plus 68. We still have plus 5y equals 172. So here, this is what we're substituting in. Okay, so then we'll end up with 4 y's. Okay, 4 y's. And then I'm going to subtract 68 from both sides. So we will end up getting 104 when we subtract the 68 from both sides. So 104 on the right. And then isolating y, we will get, let's see, 226. Okay, almost there. Our third step in solving the system, substitute y equals 26, and I'll do that into equation A, and we'll be able to solve for x. So equation A was x plus y equals 68. X plus 26 equals 68, because that's what we're substituting in for the y. Alrighty, so subtracting 26 from both sides, we will get 42. And let's put our conclusion in words. So fourth step, conclusion. Now, do you see in this case, we're answering a question, so we don't want to put it down as an ordered pair. We want to write out in words the answer. So conclusion, Krista has 42 ones and 26 fives. Okay? All right. Next problem. Melody wishes to enclose a rectangular garden with fencing, using the side of her garage as one side of the rectangle. A neighbor gave her 30 feet of fencing, and Melody wants the length of the garden along the garage to be 3 feet more than the width. What are the dimensions of the garden? Well, guys, I got to tell you, I mean, in this case, a picture is going to be worth, 1,000 words, right? So let's see what we have going on. So first step, analysis. Right. So why don't we go ahead and let, do you want to, we can let W be the width, because we're used to that, and let L be the length. And let's make our picture. So she has a garage, okay? So here's her garage. Say it's here. Okay, that's the garage. So the side of her garage is one side of the rectangle. So she doesn't need to buy any fencing for that side. So it says here that the length of the garden that's alongside of the garage. So do you see this here is going to be L. The alongside the garage will be our L. Okay. And then we'll have some, so it's a little bit different than what we're used to, but that's okay. And I don't know if these, dimensions will be very accurate, but this will also be an L, and this will require fencing. Okay. So this will require fencing, and then we have our W here and here. Okay. And actually, it's definitely not to scale as I'm reading through. Let me change my picture just a wee bit because I want it to look a little bit better. Okay. So this will be W and L. And then I'm going to go ahead and outline in the green everything that requires fencing. Do you see this requires fencing? Okay. Alrighty. So we have some information now. So now the second step is going to be to translate into math. So translating, let's check out what we've got going on. A neighbor gave her 30 feet of fencing. So what do we know? That tells us that the amount of fencing here, it's like perimeter, right? So do you see that 2 W's plus one of the L's, because we only need to fence one of the L's, has to equal to 30? And then she also wants the length of the garden that's along the garage to be 3 feet more than the width, right? So L has to be the width plus 3, right? So L has to be W plus 3. All right. So 3, solve the system. This one is nice. It's completely set up for substitution. So our first step, do you see, will be to substitute L equals W plus 3 into, if we name this equation A and equation B, we'd be substituting into equation A. So equation A is 2w plus L equals 30. So we'll get 2w plus w plus 3, because that's what L is. It's w plus 3. And that's equal to 30. Right? So that gives us 3 w's. Plus 3 is 30. 3 w's is 27. So w is 9. Okay. Second step, because we need the dimensions, substitute w equals 9 into, which equation should we do? How about B? Equation B would be ideal because L is already isolated. And this will let us solve for L. So L equals w plus 3. L equals 9 plus 3, because that's what we got for our w, right? W was 9. And so now L is 12. Our conclusion. And don't forget your units. This one had units. The dimensions of the garden are, the width is 9 feet by 12 feet. We're all done. And we're all done with section 4.2. So have a wonderful day. Don't forget to do your homework.